Hi, it's Professor Logue. In this third and final screencast for Unit 11 on authentication and account management, we'll be looking at the account management piece. What's included in account management? And then we'll summarize the key points discussed in this unit, Chapter 11. Firstly, you can see that managing user account passwords is a big job. It can be done by setting password rules, but then you have to manage those rules. Oftentimes, this is too cumbersome to manage on a user-by-user basis. You have people coming and going all the time in your organizations, and you'll have to keep track of, what changes you made to which account when. So this is a security risk, especially if you've overlooked one setting or made even a single mistake in this process. So we need something that's a better solution. We need a group policy. That's the preferred approach. So instead of assigning by individual, we assign by group. We assign the individuals by group, and then we assign the privileges to that group. So Microsoft Windows uses group password settings. There's two types. There's the password policy settings, and then there's the account lockout policy. Password policy settings are configured by using the group policy at the domain level. You've seen this in your MindTap labs. There are 6 common domain password policy settings called Microsoft setting objects. We'll see these in the next slide. Important to know for your certification exam and on the final exam. Account lockout policy is the other one, and this is an Active Directory domain services security feature. So you can set it in Active Directory domain services. So the password lockout prevents a logon after some set number of failed logon attempts. We saw this in the mobile device security unit last week. So if there's a certain number of failed logon attempts within a specific period of time, then we can specify the length of time that the lockout is enforced. So let's look at the specifics of this. What are those particular attributes that you can set, the particular settings when it comes to account lockout policies? Well, you have password reuse, password expiration, password history, password length, password complexity, and password encryption. I'll let you study this table for a second and then we'll discuss it. Feel free to pause the recording if necessary. Okay, so hopefully you had a chance to digest this table. Important thing to recognize, unfortunately there's no column headings here, but you should be able to figure it out from context what we're talking about. In the first column we have the setting. We have a description, a simple description of what's being set when you set something for that particular setting, and then a description of what that setting means, and then in the last column we have a typical value for the setting. So for example, password reuse, the first row here, this is a way to enforce the password history. So it determines the number of unique new passwords a user must use before an old password can be reused. That's why it's called password reuse. And that's from 0 to 24. So that means you have to go through 24. If it's set for 24, you have to go through 24 new passwords before, distinct new passwords, before you can reuse one that you had used previously. Password expiration, this is an interesting one. Password expiration is the maximum password age. You'll notice there's also password history, which is the minimum password age. So why do we have both of these? Well, if you think about this a minute, maximum password age determines how many days a password can be used before the user is required to change it. So the value of this setting can be between 0, meaning you never have to change it, the password never expires, and then 999 days. A typical value would be 90 days. So every quarter, every calendar quarter, a user must change their password, at least that length if it's set for 90. Now, password history, minimum password age, works in conjunction with this. As I said, this determines how many days a new password must be kept before the user can change it. So think about why you would need this. Well, let's say that a user was forced to change their password up here because of this 90-day setting. But they changed it to a password that met all the requirements, but it was just too damn hard to remember. So they changed it, and then they turn around and changed it again back to the original one. So they would be, if they didn't have a proper password reuse set, that would be allowable. But then they might also run afoul of this, which is they have to wait a certain amount of time before they can change it. So that would prevent them from doing what I just described if you set this to some non-zero value. So this is designed to work with the enforced password history up above so that users don't quickly reset their passwords and then change back to their old comfortable, familiar passwords that they're easy to remember. So the idea is we want them to keep strong passwords as much as possible all the time. Then password length is the minimum password length. 12 characters is a typical value for that. That's pretty self-explanatory. We've talked about why that's important. Password complexity, again, that increases the domain space for a number of possible passwords that would be in there. And this would help defeat a brute force attack if you just include the complexity, including not just upper and lower case, but also special characters. And this can either be turned on or off. So it's like a Boolean. It's either enabled or disabled, as is password encryption. Ordinarily, you would want to store passwords using some kind of reversible encryption, or actually not. So this provides support for applications that use protocols which require knowledge of the user's password for authentication purposes. So an attacker who can circumvent the encryption would be able to log on the network with these passwords, and typically this particular feature is disabled. And now, moving on to the account lockout policy settings that we see in Active Directory, you have, again, a table. Here we do have column headings that describe it. We have the Microsoft setting object, the description, the recommended setting, and comments. So these all deal with the account itself. So we have account lockout duration. This is the length of time a locked account remains unavailable before the user can retry it. We saw this again last week with mobile devices like the iPod example that I described. And then there's the account lockout threshold. This is the number of failed login attempts before a logout occurs, 30 invalid attempts. These questions are on the quiz, so I would make sure that I understood these two before taking the quiz this week. Account lockout duration is a length of time, whereas account lockout threshold is the number of failed login attempts before lockout. So this is interesting if you think about this. Over in the comments section for this one, it says, there's a problem if you set this too low. That may result in attackers using this to actually create a denial of service attack on you by triggering a lockout so that you can't get in. So they purposefully run the number of attempts out. If it's too low, they can do that readily. And then that locks out the user. And then that forces the user to go and get a password reset and go through all that. So this is a kind of an underhanded way of implementing a denial of service attack. And then lastly, we have reset account lockout after lockout counter after so many minutes. So this determines the length of time before the account lockout threshold setting resets. Other steps to take would be to include a shared account, a generic account, and a guest account as a prohibited type of account on your network. You would want to closely monitor any privileged accounts, disable account passwords that are no longer being used. Now notice what it says here, instead of deleting them. Think about why that would be bad, deleting the accounts. This is often a question you see on Security Plus. The reason why you prefer to disable rather than delete is because you want to be able to reactivate that account if necessary, say the employee comes back to work, or more importantly, to be able to do forensics on information in that account if it turns out that it had been used for malicious purposes. And then lastly, create strict policies regarding password recovery. The other concept that is important to know is called transitive trust. You may remember the word transitive from your math courses. You remember what transitivity meant in your math courses. If A equals B and B equals C, then it must be the case that A equals C by the transitive property. Well, we use this same idea here with so-called transitive trust. Transitive trust describes a two-way relationship that is automatically created between a parent and child domain in the Microsoft Active Directory forest. So what does this mean? It means that when you create a new domain, it will share its resources with the parent domain by default. Then you can enable an authenticated user to access resources in both the child and the parent by virtue of the transitive trust relationship. That takes us to the summary for Unit 11. These are the things we discussed. The first objective was the first 40 or so slides in your PowerPoint, which talked about all the ins and outs of password security and authentication. The what you know, what you have, what you are, what you do, where you are. Those are all different ways of authenticating. And remember, the more of those you include in your authentication process, the more secure and effective your authentication will be. We talked about the inherent weakness in passwords. It's basically because of the limitations on human memory. So we talked about ways to get around that. We also talked about the various types of password attacks, the dictionary attack, the brute force attack, the rainbow table attack, the hybrid attack. We talked about securing passwords from these attacks. Then we talked about other types of authentication credentials based on something you have. For example, a hardware token that generates a code once every 30 to 60 seconds. We also talked about biometrics, behavioral biometrics, and then in the second screencast we discussed single sign-on, what the advantages are of that, and what the various frameworks are like OAuth to implement it. And then lastly, in this screencast we looked at group policy settings to be able to effectively manage more efficiently all of the password restrictions for an entire group at once. That concludes the Unit 11 content. If you have any questions, feel free to go back and revisit some of these slides. But as always, it's important to take a look at the content that's in your book. Also, be sure to check out the other references that I've provided for you on the screencast page from which you selected this link. You'll find there a more detailed description of rainbow tables than what was provided in your book, including a sample implementation with a simplified version of a rainbow table using an Excel spreadsheet. If you're mathematically inclined, I think you will find this particularly interesting to recognize and appreciate how rainbow tables can be used to hack passwords. Of course, that said, you should also know the various means that we discussed for trying to mitigate the risk that's posed by rainbow tables vis-a-vis salts. Okay, if that's all I have for this particular unit. Please be sure to check out the office hours, or if you have any questions, feel free to send me a Canvas message.